a storm with a force of 12 on the Beaufort scale, technically classified as a hurricane, represents the most extreme and violent weather conditions that any vessel can encounter in the open ocean. At this level, the wind speed exceeds 118 kilometers per hour, over 73 miles per hour, and the sea is no longer just water. It becomes a chaotic, white landscape of driving spray and foam. Visibility drops to nearly zero, and the ocean transforms into a series of massive, moving walls of water. For any ship crossing the world's oceans, these storms are the ultimate test of engineering and human endurance. Even the largest cargo vessels, built from thousands of tons of high-tensile steel and designed to withstand the harshest environments, must rely on flawless navigation, structural strength, and the vast experience of their crews to survive. When a Force 12 storm strikes, the first and most immediate factor affecting the vessel is the wind. Hurricane force winds exert immense, unrelenting pressure on all exposed surfaces of the ship. In the shipping industry, this is known as windage. For modern container ships, which carry thousands of boxes stacked high above the deck, the windage area is enormous. This pressure can push a massive ship sideways, a phenomenon sailors call leeway or drifting. Depending on the wind's direction relative to the ship's heading, it can cause a dangerous heel or permanent tilt. The severity of this impact depends on many variables: the ship's overall size, its aerodynamic shape, the current cargo load, and the draft, the portion of the hull submerged in water. The higher a ship sits above the waterline, the more vulnerable it becomes to these invisible but powerful atmospheric hammers. The position of the ship's center of gravity and the precise distribution of its cargo are critical to its survival. A well-balanced, seaworthy vessel reacts more predictably to the violence of the wind and waves. In contrast, a poorly balanced ship, perhaps one with too much heavy cargo placed too high, can begin to sway dangerously from side to side, losing its ability to right itself after a heavy gust. However, as dangerous as the wind is, it is only one part of the equation. The waves generated by a hurricane-force storm are often the most destructive force a ship will ever face. During a severe oceanic storm, wave heights can regularly reach 10 to 15 meters, and in extreme cases, rogue waves can tower even higher. These giant, moving walls of water strike the ship repeatedly, delivering blows equivalent to hundreds of tons of force per square meter against the hull. As a vessel navigates through such mountainous seas, it experiences several complex types of movements simultaneously. Pitching. The bow and stern rise and fall rhythmically, sometimes lifting the propellers out of the water or slamming the bow into the next wave with bone-shaking force. Rolling. The ship tilts from port to starboard. This is perhaps the most dangerous movement for cargo stability. Yawing. The ship's nose swings left and right, struggling to maintain its heading as waves strike it from the quarters. Heaving and surging. The entire mass of the ship is lifted vertically by the swell and pushed forward or backward. The most critical danger occurs when the rhythm of the waves coincides with the ship's natural period of roll. This phenomenon is known as resonance, specifically parametric rolling in container ships. In a state of resonance, each subsequent wave amplifies the ship's tilt, making the motion increasingly violent and uncontrollable. In extreme cases, this leads to the snapping of steel lashings, the shifting of thousands of tons of cargo, and the potential structural failure of the ship's back. Another severe threat is green water on deck. This happens when massive waves wash over the bow and the superstructure, flooding open areas and smashing expensive equipment. The bridge windows of large ocean-going vessels are designed to withstand incredible pressure, but history has shown that even these thick, reinforced panes can be shattered by the sheer weight of a collapsing wave. In colder climates, ships face the added nightmare of icing. As seawater spray freezes onto the ship's superstructure, it creates a thick layer of ice. This adds thousands of tons of top-heavy weight, raising the center of gravity and increasing the risk of a sudden capsize. In extreme weather, Cargo ships face unique challenges compared to passenger liners. A cargo ship's stability depends almost entirely on the weight and arrangement of its freight. Paradoxically, a fully loaded ship often handles a storm better than an empty one. The weight of 100,000 tons of cargo lowers the ship's center of gravity and increases its draft, helping it grip the water and remain stable. An empty ship, however, sits high in the water like a cork. This makes it a victim of the wind and causes it to roll sharply and jerkily. To combat this, engineers use ballast tanks, filling them with seawater to add weight and improve metacentric height. But ballast is not a perfect substitute for a properly distributed cargo load. Even with full ballast tanks, an empty vessel can experience violent motions that stress the hull's welds and internal framing. Modern cargo ships are masterpieces of engineering. Their hulls are constructed from thick steel plates designed to flex slightly under the pressure of the ocean. Yet, the ocean remains unpredictable. If waves are strong enough and strike the hull at certain angles for a prolonged duration, they can cause metal fatigue or structural failure. In rare but dramatic instances, ships have been known to break their backs and split in two under the strain of a force 12 storm. The American-flagged ro-ro ship El Faro was on its regular route from Jacksonville, Florida to San Juan, Puerto Rico, when it sailed directly into the path of Hurricane Joaquin, a Category 4 monster. Near the eye of the storm, the ship lost propulsion, leaving it helpless against 15-meter waves and force 12 winds. The vessel took on water through an open scuttle, and as the cargo of trailers shifted, it lost stability and sank in the Atlantic. This tragedy resulted in the loss of all 33 crew members and remains a haunting lesson in the dangers of weather miscalculation. The Stellar Banner, a very large ore carrier carrying 275,000 tons of iron ore, was traveling from Ponta da Madeira, Brazil to Qingdao, China, when it encountered severe weather shortly after departure. The structural strain from the heavy iron ore, combined with the relentless wave impact, led to critical cracks in the hull. To prevent the massive ship from sinking in deep water, it had to be intentionally grounded off the coast of Maranhão. The vessel was later scuttled after being declared a total loss. While crossing the North Pacific on its route from Yantian, China to Long Beach, California, the one Apus encountered a violent storm cell with winds reaching force 11 to 12. The ship suffered from severe parametric rolling, a violent motion that caused the steel lashings to fail. As a result, 1,816 containers tumbled into the ocean in one of the greatest cargo losses in history. Photos of the ship arriving in Japan later showed a war zone of twisted steel and dangling boxes scattered across the deck. Both sister ships fell victim to the brutal North Pacific winter while traveling from China to Los Angeles. In January, the Maersk Essen lost 750 containers due to heavy rolling in a storm. Only weeks later, the Maersk Eindhoven suffered a catastrophic engine failure during a force 12 gale. Left at the mercy of the waves, without power to steer into the wind, the ship rolled violently, dumping another 260 containers overboard into the freezing sea. The Zim Kingston was nearing the end of its journey from Busan, South Korea to Victoria, British Columbia, when it was hit by a massive atmospheric river storm bringing hurricane-force gusts. While waiting to enter the port, the ship lost over 100 containers due to extreme motion. The disaster escalated when the remaining cargo shifted, causing a chemical fire on deck that burned for days, highlighting how storm-induced cargo shifts can lead to secondary life-threatening dangers. Despite these risks, thousands of cargo ships cross the world's oceans every day, transporting the goods that power the global economy. From smartphones and automobiles to food and clothing, nearly everything used in modern life has traveled across the sea at some point. Surviving the most violent storms depends on several critical factors: the strength of the ship's design, proper maintenance of the vessel, careful cargo loading, and most importantly, the skill and experience of the crew. When a Force 12 storm strikes, there is no way to stop the ocean. The only option is to work with the ship, adjust the course, reduce speed when necessary, and rely on training and engineering to endure the storm. In the end, the battle between ships and the sea has always been one of endurance. Technology continues to improve, ships continue to grow larger and stronger, but the ocean remains one of the most powerful and unpredictable forces on Earth.